Hello, good evening, Alexander and Steve.
Hi, sir. Good evening.
Hmm. All right, so how are you, Alexander?
Sir, I'm fine. How are you?
I'm also fine, thank you. Okay, so in the last session, we were discussing about the measures of dispersion, wherein we have discussed the concept such as standard deviation, the mean deviation by the mean method, right, and the combined standard deviation as well. Okay,
Yes, sir.
so do you have any doubt regarding those topics? You want to ask anything?
No, sir.
No.
It's clear.
Okay, so before moving forward, I just want to do few questions based on the previous concepts, and then we will start with a new concept, which is coefficient of variation. So, is this question visible to you on screen?
Yes, sir.
I don't know whether it is visible to you clearly or not, since because it is written very small. The mean of two sample of size 50 and 100 are respectively are 54.1 and 50.3, and standard deviation are 8 and 7. Find the mean and standard deviation of the sample size 150 obtained by combining the two samples. Is it clear to you?
Yes, sir.
Okay, so you need to find out the combined standard deviation in this question, Alexander. So will you be able to solve this question? I'm
Okay,
giving
sir.
you 5-6 minutes. Solve it. Do let me know the answer, and then we will do one or two more questions based on the previous concepts only, and then we will start with a new concept, coefficient of variation.
Okay, sir.
All right.
Sir, I'm supposed to find the combined standard deviation.
Yes.
Okay.
Dan Alexander.
Sir, I just found the combined mean.
We just found the combined mean. Okay. And what is the value of combined mean?
Sir, 1 second. So 51.56.
Yeah, that is correct. 51.56.
Sir, I'm getting combined mean as 57.2.
Combined standard deviation.
Yeah, sir.
Sorry, how much?
57.2.
57.2. But the combined standard, the correct answer is 7.56, Alexander. It should be something around 7 point something.
Okay.
Okay, just tell me what values you have put while calculating the combined standard deviation. So just a minute. Combined standard deviation. Could you just tell me the value of d1 square?
Sir, 6.45.
6.45, all right. And then d2 square?
1.58.
1.58, all right. It is near. And then okay, now tell me what values you have put while writing the values in the standard formula, standard deviation formula. So in place of n1 you have put 50
Yes.
multiplied with the square of the standard deviation.
Yes.
And what is the square of the standard deviation?
64.
64 is the square of standard deviation. 64. How did you get okay? Oh, all right. And then n2 the value of n2 is
100.
100 multiplying it with the 49, right?
Yes. Yes.
Then number of items in the first series again 100.
It's 15.
50, okay, 50. And we will be multiplying it with the d1 square. So d1 square is 6 point
45.
something. Okay. And then n2 100 into
1.58.
okay divided by n1 plus n2, that is 150.
150.
You have done everything correct. Why then there is a difference? Just let me check.
Sir, I solved all the brackets first.
You solved all the brackets. So after solving the brackets, just I don't know why your answer should tally. Neb. I don't know why it is not tallying. The correct answer is 7.56. Okay, no problem. Let me do this. Just tell me the values. Standard deviation, combined standard deviation of the first and second series equals to under root and one is 50 into the square of the standard deviation of the first series, that will be 64.
So
Then
we have to underroot it.
yes, we need to underroot it.
Oh, I didn't write that.
Yeah, okay. So that is why what was the answer you got? 50?
It is 56.16.
56.16. And when you will underroot it, you will get 7.4. Yeah, now you are getting the right answer. 7.49 will be the answer.
Okay.
Okay, so that is the mistake.
Yes, sir. In the formula, I didn't write underroot for some reason.
No, there was underroot as well.
Yes, my mistake.
No problem. Okay, now let's now talk about the coefficient of variation. So what is, first of all, what is coefficient of variation? That we need to understand, and then we will do question based on coefficient of variation. So just like any other tool, coefficient of variation is also a statistical tool. It is also a statistical tool, and the purpose of this tool is to find out the consistency. In order to find out the consistency, or you can say the stability, we apply this statistical tool. So let's suppose if we want to compare let's suppose if we want to compare the two different companies, if we want to compare the performance of two different companies, and performance is being measured on the basis of their profitability, they have the profit they have generated in the last 10 years. So in order to say which company is more stable or more consistent in terms of the profitability, what we will be doing, we will be comparing their profits side by side, profits of the A company, and then we will compare it with the profit of the other company, B company. Okay. So but the thing is that we want to find out which company is more consistent in terms of the profit generation. So in order to find out the consistency of the company in terms of the profitability, we can apply the coefficient of variation. Think like that suppose you are a shareholder, or you are a prospective investor. You want to make investment in these company. Now you want to decide in which company you should invest, whether you should invest in the company A or you should invest in the company B. So your investment should be based on the profitability. So how much and how consistent the company has been in the past in the profit generation, right? So if you as an investor want to know the consistency of a company in with respect to the profit generation, what you can do, you can apply this method by which you can find out the consistency. So method is coefficient of variation. So coefficient of variation is nothing but a statistical tool which is used to measure the consistency or the stability of anything. When we compare two things or two subjects, and we want to decide which is more consistent, which is more stable, then we can apply this. tool. Now this can also be used in such a situation. Let's suppose we are talking about two batsmen. Alexander, you watch cricket?
No, sir.
You don't watch cricket. So let's suppose we talk about, let's suppose we are talking about a footballer. So you watch football?
No, sir.
You don't watch football as well. So which game you watch?
No, it's fine. You can explain with cricket.
Okay, so do you have any idea na, how cricket works?
Yeah, a little bit.
Okay, so we have two cricketers. Let's suppose we have two cricketers from Indian teams. We have Rohit Sharma. Ever heard of them? Rohit Sharma and the Virat Kohli. Virat and Rohit.
Sir, I only know Virat Kohli.
Well, you know Virat Kohli. Wow. Okay, so Rohit Sharma and Virat Kohli is there. And now let's suppose there is going to be a series with and wherein Indian team is going to face the Australia and India. There is going to be a series between the India and Australia, and between both these batsmen we need to select only one. Either we can select Rohit Sharma or we can select Virat Kohli. So obviously at the time of selection of the player, what do we consider? We will be considering their consistency in the game, how consistent they are, how consistent they are with their performance, right? So in order to determine the consistency of the players, what tool we can use? At that time we can use the coefficient of variation. Okay, and generally how does it work? See, by applying coefficient of variation, what do? We calculate the value of the variation. We calculate the coefficient of variation in terms of some numeric value. So there will be some numeric value of the coefficient of variation. Okay, and generally player having or any subject having high coefficient of variation indicate low stability or poor performance or poor consistency. Getting my point? High coefficient of variation indicate low consistency. Player having high coefficient of variation indicate low consistency, and similarly player having low coefficient of variation indicate that that player will be more consistent, highly consistent. Same goes with the selection of a company. If you as an investor want to decide in which company you should invest your money, then that time you will be calculating the coefficient of variation for both the companies, and company having the high coefficient of variation indicate that company is not very stable with respect to the profit generation. Company is not very you can say the consistent with the profit generation, and then accordingly you can decide if a company is not generating profit consistently, then we should stay away from such kind of company. So this is how coefficient of variation is used. Now let's talk about the formula. So formula for calculating coefficient of variation is pretty simple. The formula is simply, what do? We first of all calculate the standard deviation of a series, and then we divide it by the mean, and multiplying it with the 100 we will get the coefficient of variation. So let's suppose if a standard deviation of a particular series or for a particular player is, let's suppose it is 25, and the mean of the series is, let's suppose, 8. So 25 by 8 and into 100, whatever the value that we will get, sorry, it should not be. But let's suppose standard deviation is 6 and mean is 20. So we will multiply it with the 100. So accordingly, we will get the value of the coefficient of variation. For, let's suppose that we are calculating it for company A. So this is how we will get the coefficient of variation for company A. And similarly, we will calculate the coefficient of variation company B as well. And then we will compare both these company having high coefficient of variation indicate low consistency, and we are not going to select such kind of company, or if we, let's say if we are talking about the player, then we are not going to select such kind of player. Tell me, is this clear to you, Alexander?
Yes, sir.
Okay, so this is how the coefficient of variation can be used. So just a minute. Okay, so coefficient of variation is a statistical tool which is developed by the Carl Pearson, and it is important relative measure of dispersion. As at the very beginning of this chapter, we have already understood that dispersion can be broadly categorized into two parts, which is absolute measure of dispersion and the relative measure of dispersion. So coefficient of variation is the relative type of dispersion. Okay, and it is used in comparing the variability, homogeneity, stability, uniformity, consistency. So these kind of things we can determine using coefficient of variation. And as I told you, higher the CV, higher the coefficient of variation, lesser will be the consistency of a particular subject. And then the formula for calculating coefficient of variation is standard deviation divided by mean into 100. Got it?
Yes, sir.
So let's move to the question. So let's start with the okay. So first question is regarding a batsman. So let's start with this question only. So the question says that the score of two batsmen A and B in 10 innings during a certain match are 32, 22, 28, 47 and so on. Player B have scored 19, 31, 48, 53 and 67 so on. Now we need to decide that which batsman is more consistent with the game, with the performance, who is more consistent in scoring runs. And depending upon the consistency, we will pick one batsman, let's say, for the next series. Okay, so let's suppose for the time being that the player A is Rohit Sharma and player B will be the Virat Kohli, let's suppose. So Rohit Sharma have scored these runs in different innings, and Virat Kohli have scored these runs 19, 31, 48 and 53. So considering the performance of the two players, we need to decide which player is more consistent. So without calculating the coefficient of variation, there is a possibility that you might not be able to pick up the right player. But on the basis of coefficient of variation, we will be in a position to decide which batsman is more consistent with the performance. So looking at the runs scored by the two batsmen, we are not sure which batsman is more consistent and which player should be selected for the next series. So let's do this question. Let's start with this question and try to understand how coefficient of variation is calculated. Any doubts?
No, sir.
No doubts. So first of all, we will write down the values of the question. So player A and player B. So the runs scored by player A, I'm assuming it as X variable. I'm considering the runs scored by player A is X and runs scored by player B is Y. Okay, and then I'm going to write down their scores. Okay, so run scored by player A, player X, 32, 28, 47, 32, 28, 47, 63, 71, 39, 10, 60, 96, 14, 60, 96 and 14. And similarly, runs scored by second batsman is 19, 31, 48, 19, 31, 48, 53, 67, 90, 10, 62, 40 and 80 and 80. Okay, so these are the runs scored by two batsmen in different innings. Now we need to find out the coefficient of variation for both these batsmen. So first of all, we will be calculating the coefficient of variation for the first batsman. So batsman A. So coefficient of variation for batsman A will be calculated as COV, coefficient of variation, equals to standard deviation of the first batsman divided by the mean of the first batsman into 100. Okay, so standard, let me write, just to differentiate, I'm writing standard deviation of A batsman and mean of the runs scored by A batsman, and I'm finding coefficient of variation for the A batsman. And similarly, we need to find out the coefficient of variation for the batsman second as well. So batsman B, coefficient of variation for B. Formula will be same, standard deviation for B divided by mean of the B into 100. We will get the coefficient of variation. Okay. So first of all, let's talk about only X. So in this question, the first requirement is to calculate the standard deviation, right? Unless and until you find out the standard deviation, you won't be able to find out the mean, sorry, the coefficient of variation. So for that purpose, in order to find out the standard deviation, we will be preparing a working note. Alexander, do let me know if you have any difficulty understanding anything. Okay.
Okay, sir.
Okay, so standard deviation for batsman A. So standard deviation for batsman A will be calculated as standard deviation of batsman A. Tell me which formula you want to apply for calculating standard deviation. Standard deviation of batsman A. We will be, let's apply the actual mean method formula, right? So the actual mean method formula for individual series will be sigma x square upon n, right?
Yes, sir.
And here x, what is the meaning of x? X means deviation, square of the deviation. So let me simplify it for you. Here sigma x square means the square of the deviation. So this is how we are going to calculate deviation, x minus mean divided by n. So before calculating anything, we have to calculate the mean of the for the batsman A. So for that as well, we will be preparing the another working note, mean, and this mean is being calculated for batsman B, batsman A, sorry. The formula for calculating mean in case of individual series is sigma x upon n, right, Alexander? You remember this now?
Yes, sir.
Okay, so let's total all the runs scored by batsman X so as to get the sigma x. So sigma x will be 32 plus 28 plus 47 plus 63 plus 71 plus 39 plus 10 plus 60 plus 96 plus 14. So it is 460. 460. And obviously we have 10 items score because the scores of these batsmen is given with respect to the 10 innings. So 460, we will divide it by the 10. So the mean of the for the first batsman, mean run scored by first batsman will be 46. Okay, now we will be able to calculate the deviation of the first batsman. Is this clear to you, Alexander?
Yes, sir.
Okay, now so I'm making another column for calculating the deviation. So for deviation, we will apply this formula x equals to x minus mean. And after finding the deviation, we will do the square of it, x square. Okay, so you can do that now. You can find out the deviation x minus mean, 32 minus 46, then
Yes, sir.
28 minus 46, 47 minus 46, right? So
Yes.
I'm skipping that for now because you can do this. So I'm moving to the next part. After calculating the deviation, we will square all the deviations so as to find out the sigma x square. And after finding out the sigma x square, all you need to do is to put this value into the formula here, in the standard deviation formula here. And after putting it here, you will be able to find out the standard deviation. Once you got the value of the standard deviation for a batsman, all you need to do, put the value of the standard deviation at here, and divided by the mean we have earlier calculated, 46, and multiplied with the 100. This is how you will be able to calculate the coefficient of variation for batsman A. Is it clear to you?
Yes, sir.
Okay. So for now, I'm leaving. I'm skipping that part. You will be solving it. I'm moving forward. Now let's talk about the batsman B. Now batsman B, again, in order to calculate the coefficient of variation for batsman B as well, we need to find out the standard deviation for B and mean of the B as well. So for that as well, we need to prepare a working note again. So let me prepare a working note here. So here we will be finding out the standard deviation for batsman B. Same formula will be applied. This time, because we have taken as the score runs scored by batsman B, we have taken it as y variable. So I'm writing it as sigma y square divided by n. Okay, is this clear to you?
Yes, sir.
Okay, and to find out the standard deviation or the y square, we have to find out the mean, so as to find out only then we will be able to find out the deviation of y. So y sigma y square actually means y minus mean of the y series, and then we will square it, and then we will divide it by the number of items. So that means for the y variables as well, we need to find out the mean. So we will be finding out mean for the batsman B, and that will be calculated as sigma of y divided by total number of items. Okay, so let's total these variables of y. 19 plus 31 plus 48 plus 53 plus 67 plus 90 plus 10 plus 62 plus 40 and plus 80. So the sum total of the y variables will be 500. 500 and total items are 10. So mean will be 50. Got it? After finding out the mean, now we will find out the deviation of y. So for finding out the deviation of y, we have to make few more columns. Y, that is deviation of y, equals to y minus mean of y. And after finding out the deviation, we need to square all the deviation. We will be finding out the y square. And after finding out the y square, we will be totaling all the values of the y square, sigma y square. And whatever the value we will get here, we will put this into this formula. We will put it here, right? And we will calculate the the standard deviation. And once we get the standard value of the standard deviation, then we will put the value of the standard deviation at this point here, and we will put the value of the mean we have earlier calculated, and then we will calculate the coefficient of variation of the batsman second as well. And after calculating the coefficient of variation for both the batsmen, what we will be doing now, we will be comparing the variation coefficient of variation for both the batsmen, and the lowest low coefficient of variation will indicate that that particular batsman will be more consistent. Okay.
Yes, sir.
So okay, so do it now. Complete all the remaining part. Let me know the correct answer, which is more consistent, and then we'll move to the next topic. Next question. Okay. You want me to show you any specific part of the solution? Do let me know, and accordingly I'll scroll down.
Okay.
Alexander, any doubts? Any problem?
No, sir.
No. Okay, so let's just do one thing. So can you just finish it after the class as a homework, and can we move to the next question or next topic?
Okay, sir.
Okay, na? All right.
Yep.
So just a minute, because I have explained everything. I think remaining part you can do it yourself as well.
Yes, sir.
All right. Now, so just let me tell you the correct answer, and the answer will be that in case of the batsman A, the coefficient of variation will be higher, and the coefficient of variation for the batsman B will be lower. That means the coefficient, since the coefficient of variation for batsman B is low, that means that means batsman B will be more consistent. Okay, so make sure when you got the answer, when you get the answer, so make sure that B should be the more consistent. You should get the low coefficient of variation for the batsman B. Otherwise, your answer will be incorrect. Got it?
Yes, sir.
Okay. So moving on to the next topic, and okay, let's talk about the Lorenz curve. This is the last topic of this chapter, Lorenz curve. Okay, so what is a Lorenz curve? Again, it is also a statistical tool that gives you a graphical representation of the inequality, income inequality or wealth inequality in an economy. That means Lorenz curve is also used to find out the variability or the variation in a series, but Lorenz curve is generally, most of the time it is used in context of the income inequality and wealth inequality. So whenever we want to determine that whether income is equally distributed in an economy or not, or wealth is equally distributed in an economy or not, that time Lorenz curve can be useful. We can say that there is a very narrow use, very narrow scope of use of Lorenz curve, since it is not used every time. It can only be used when we want to find out the income inequality in an economy or wealth inequality in an economy. Generally, that time we use Lorenz curve. Or if we want to find out the variability in the salary or the wages of different workers working in two different companies. So let's say if workers are working let's suppose 10 workers are working in factory A, and then there are 10 workers who are working in the factory B, and we want to find out how their wages differ, what is the degree of variation in their wages. That time we can use Lorenz curve. So there is no, you can say the scope of the Lorenz curve is narrow. It is not widely used. It is not applicable everywhere. It cannot be used for calculation of every kind of variation. First. Second thing is that on the basis of Lorenz curve, you won't be able to find out the exact magnitude of the dispersion. You will be able to only determine the whether two two groups are there is a too much variation among the two group, or there is very less variation in two groups. Only that. You won't be able to find out the exact value of dispersion, like we used to do while calculating the mean deviation, standard deviation, or the coefficient of variation. In all the other method of finding the dispersion, you will be able to calculate the exact value of the dispersion. But in case of Lorenz curve is just a graphical presentation of the variation of the income or the wealth difference of two different segments. That's it. You won't be able to find out the exact value of dispersion. So this is how Lorenz curve is generally drawn. We have two axes, and on this axis we will be presenting the values for group A and group B, and accordingly this kind of pictorial representation will be formed. Lorenz curve is used to represent economic inequality as well as unequal wealth distribution. The farther away the curved line is way from the straight diagonal line, the higher the level of inequality. So let me explain this a little more. Just a minute. Okay. So how do we actually prepare a Lorenz curve? This is how we actually prepare a Lorenz curve. We take this axis, x-axis and the y-axis. After preparing an x or the y-axis, then we prepare a straight line starting from the origin. Okay, and just a minute. This kind of straight line form will be formed from the starting from the origin, and this line is called the line of equal distribution. This is called line of equal distribution. Okay, so this is the basic structure of the Lorenz curve. After that, in the question, as per the question, let's suppose there are two variables given in the question or two segments given in the question. Information about two segments is given and their values will be given. Let's suppose 10, 20, 30, 40, 60, something like this. And then value of the y variable will also be given for 20, 60, 90, 10. This kind of values will be there. So we need to do certain calculation with respect to the values, and after doing the calculation, what we will be doing, we will be plotting the value of the x variable on the graph, and then we will be plotting the values of the y variable. Let's suppose I have plotted the values of the x variable. So one point is plotted here, then the next point, and the next. Just and this kind of this is how all the values of the x variable is plotted on this graph. And after plotting all the values on the graph, what we need to do, we will connect all these lines through a curve. Okay, so this is basically the graphical representation of the values of x variable. So I will write down group A or group X. This line is indicating the value of the group X, and similarly I'll have to plot the variables of the y variables as well. And when I plot those values, this kind of graph will be formed. And this is how I have plotted all the value. And after plotting all the values, what I'll be doing, I'll be connecting all these values through a line. Okay, so this line indicate the dispersion of the group Y from the line of equal distribution. Now, on the basis of the after the presentation of the various values on the graph, how are we going to decide which is in which case dispersion is higher, whether in case of group X or group Y, in which case dispersion is higher? So for that purpose, we compare both these lines with the line of equal distribution. So the line of variable which is falling away from the line of equal distribution have the greater degree of dispersion. So in our example, line for the variable X is farther from the line of equal distribution. So that indicate that group X has high degree of variation. That means high degree of dispersion. And group Y, since it is closer to the line of equal distribution, that means there is a low degree of dispersion. So this is how we come to the conclusion that in which case the degree of variation or the dispersion is higher. Now you can see that in while solving this, we are not finding the value of dispersion on the basis of any particular value. We are just plotting all the values on the graph, and on the basis of graph we are deciding that in which category there is a greater degree of variation or the dispersion. This is it. So this is how the structure of the Lorenz curve is basically formed. So we will be doing few questions based on this, so you will be in a better position to understand this concept, but this is how actually Lorenz curve will be formed. Tell me, Alexander, everything is clear to you? Do you have any doubts?
Yes, it's clear.
It's clear. Okay, so just a minute. Coming back to the PowerPoint. Now see, let's read the second statement again. The Lorenz curve is used to represent the economic inequality as well as the unequal wealth distribution in an economy. Farther away the curved line is way from the straight diagonal line. That means farther the line from the line of equal distribution, the higher will be the level of inequality or the higher degree of the dispersion. And similarly, closer the line to the line of the equal distribution, lower will be the degree of variability or inequality or dispersion. Now, the graph plot. Okay, now let's move to the question. So this is the question, Alexander, and from in this question we have the data of two forms, form A and form B, and the data give you the information about the profit generated by form A and form B in different years. So we have 5 years. We have given you the data of 5 years. Form A have generated 15. Let's suppose all the information is in terms of lakhs. So in 2001, form A was generating 15 lakhs of revenue, and form B was generating a profit of 20. Then in the 2002, 30 and 30, and accordingly in different years, different profits have been generated by two different companies. Now we need to present this information on the Lorenz curve. Okay.
Okay.
First of all, write it down. Write down the question. Then I'll start with the solution. You can also take the screenshot if you wish to. Just a minute. Just a minute. So one thing that you need to understand in this topic is that before drawing the Lorenz curve for any question, we need to do certain calculation. We cannot draw the Lorenz curve directly. We have to do certain calculation. And for that purpose, we have to make columns. We have to, since we need to calculate certain values, so we will be doing that by preparing columns. Just a minute, let me write down all the values first.
Sir, do we need a graph paper?
Generally, we do not require graph paper, but there is a possibility that your school may provide graph paper at the time of examination. But this kind of question can be solved without the graph paper as well. But it will be better if they provide you the graph paper. It will be more convenient. It will become more easier for you to plot the values. Okay. So first of all, what we will be doing. So first of all, let's write down the years. And in different years, profit of the firm A. Firm A profits. So 2001, 2002, 2003, 2004, 2005. Okay. 2001, 2002, 2003, 2004, and 2005. Profit generated by firm A in different year is 15, 30, 45, 60, and 50. 15, 35, 45, 50, and 60. Sorry, 60 and 50. 60 and 50. Okay. So I'm not writing the profit of the firm B right now. We will be doing that later. But now pay attention. What we need to do, we will be finding out the cumulative profit of the firm A. We will be doing the cumulative, like just like we used to do the, we used to write down the frequency, and then we used to calculate the cumulative frequency. Do you know how to do that? From frequency we used to calculate cumulative frequency. You already know now how to find out the cumulative frequency.
Yes.
Okay, so in the same manner we will be finding out the cumulative profit generated by firm A in all 5 years. So I'm going to write here cumulative profit. Firm A. Okay, so cumulative profit will be 15. Then we will add 30 to it, 45. Then we will add 45 again, 90. Then 90 plus 60, it will be 150. Then 150 plus 50, it will be 200. Is that clear to you?
Yes, sir.
Okay. Now what are we going to do, Alexander? We will now convert all the cumulative profits into the in terms of percentage. So profit in terms of percentage. In cumulative profit in terms of percentage. Okay. Now we will be calculating, we will be converting it into percentage. Considering this as a base, we will be calculating the percentage of profit generated in different years. So let me show you how it will be done. So you will be considering 200 as the base, 200, and on the basis of this you will be calculating the percentage. So 15 by 200 into 100. Okay, so this will be the profit of the firm A. So it will be 7%. Got it? Is this clear to you?
Yes, sir.
And similarly, profit of for the year 2002 will also be calculated in terms of percentage. So it will be 45 divided by 2. So it will be, I think, 23 point, no, sorry, 22.5. Then 45%, then 75, and then finally 200 divided by 200, it will be 100%. Got it? Is this clear to you?
Yes, sir.
Okay. So we need to take these steps in terms of with respect to firm A, and similarly we will be taking the same step for the firm B as well. So now let me write down the values for the firm B. So firm B, profit generated by firm B. Firm B profits. Profits of firm B are 20, 30, 45, 60. 20, 30, 45, 60, and 45 again. Okay. Now what we need to do, we will be converting, we will be calculating the cumulative profit of the firm B as well. So cumulative profit of firm B. Okay, so in order to find out the cumulative profit, we will be adding 20 plus 30, 50, 50 plus 45, it will be 95, 95 plus 60, 155 and 200. And then after that, we will be calculating the cumulative percentage of profit. So cumulative profit in terms of percentage. Okay, and percentage we will calculate again 20 by 200. It will be 20 upon 200 into 100. It will be 10%. And similarly, it will be 25%. Then 95 divided by 2, 47.5%. And 77.5%. And 200 divided by 200, it will be 100%. Tell me, Alexander, is this clear to you?
Yes, sir.
Okay. So it is simple. Just it takes you to basically you need to draw a lot of columns, and only after drawing these columns you will be able to draw the diagram. Now among all these columns, only 2 columns are relevant for the presentation of the drawing of the graph. We will require this column only, and we will require this column only. This is it. Out of all these columns, we will require only 2 columns in order to prepare a Lorenz curve. So have you noted it down, or you're still writing it?
Sir, I'm writing. 1 second.
Okay.
Okay, sir, done.
Done. Now we will be drawing a graph. Okay. So we will write down the profit generated by firm A on the x-axis. Profit generated by firm A on x-axis, and profits generated by firm B on y-axis. And obviously all these profit will be presented in terms of percentage. Their values won't be presented this time. They will be presented in terms of percentage only. Just a minute, Alexander. It will take some time for me to draw diagram on this.
Okay, no problem.
Okay, so this is how we will be drawing the graph, and all the values will be presented in terms of percentage. So I'm taking a gap of 10%. So 10%, this will be 20%, 30%, 40%, 50, 60, 70, 80, and 90. And it's 10%, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay. Now we will draw a line of equal distribution, and line of equal distribution. I'll start the line of equal distribution from the point of origin, and I will end it exactly at the 100% point for both the axes. So just a minute. Okay, so somewhere at this point, okay, now I will interconnect these points. Okay, so this will be our line of equal distribution. So let me write it here. Line of equal distribution. Okay, any doubts till this point?
No, sir.
No. Okay, now we will start plotting the values. So it won't take a lot of time if you solve it on your notebook. Since I'm working on this notepad, it takes a lot of time to draw the diagram especially. Okay, moving on to the values. Now we need to consider only these values. Percentage of profit generated by firm A. So in the 2001, we have this 7% here, and we have here 10%. So what we will be doing, we'll go to the 7% and 10%. No, 7 and 10. Okay, so 7% and 10. 7% of the x-axis, I mean the profit of firm A, and 10% of firm B. So 7 will be somewhere near this point, and 10% will be here. So this will be the first point indicating 7 and 10%. Got it? Is this clear to you?
Yes, sir.
Okay. Now we will consider the second value, 22.5%, 25%, 22.5% of A and 25% of B. So 22.5 and 25. 22.5. Let's suppose it will be somewhere at this point, and 25 will be here. So we need to draw we need to take a point somewhere close to this point. Okay. So this will be our second point, second dot. Let's just do one thing. Let's write down this line of equal distribution below the line. Okay, then we will plot the next value, 45 and 47.5, 45 and 47.5. So 45 will be somewhere here and 47.5 will be near 50%. So okay, so I guess this should be the point. Okay, after that we have just a minute, 75 and 77.5. So 75% will be here and 77.5 will be near 80%. Okay. And then after that we have, I think the last point is 100% and 100%. So last point will be here, 100% and 100%. Okay, so we have plotted all the values on the graph. Now we will connect all the dots with a line. So but just make sure that you take a 0 point as well. You start the line from the point of origin only. So we will consider that at 0 the profit generated by both the firms will be 0%. So 0 0. Now we will connect this through a line making a Lorenz curve. Okay, so this kind of curve will be formed. This will be called Lorenz curve. We have this time we have made a Lorenz curve combined Lorenz curve for both the form A and form B, but in different question you will have to prepare a Lorenz curve for these two form differently. We have to draw two Lorenz curve, but in that case information will be there should be some different values in the question, otherwise we won't be able to prepare two different curves. Got it, Alexander? Is this clear to you?
Yes, sir. Clear.
Clear. So this is how we will be preparing the Lorenz curve. Okay, so this is the last topic of this chapter, and I would suggest that you solve few questions based on Lorenz curve from your textbook as well. And just a minute, let me give you one question for homework so that you can solve it on your own as well. Okay, so this is the question. All right, Alexander. So this is the question. We have the daily incomes here in terms of class interval 0 to 100, 100 to 200, 200 to 300, and like this. Factory A and factory B is there. Okay, and we need to present the information in the format of the Lorenz curve. So in this example, in this question, you have to prepare the two Lorenz curve for factory A and factory B as well. Like it is written in the question that the given table shows the daily income of workers of two factories. Draw the Lorenz curve for both the factories. So we need to prepare two Lorenz curve. Got it?
Yes, sir.
Okay. So let me just take the screenshot of this question and
Yes. Done.
done. Then let me show you the solution of this as well. See, this is how it will be solved. So what we will be doing, we will first find out the mid value of the daily income, then we will convert the incomes into cumulative mid values. Then from the cumulative mid value, we will find out the percentage of the income. Getting my point? Then again, we will find out the cumulative frequency of the workers, then we will find out the percentage of the workers. And similar, this is for the factory A. And similarly for the factory B as well, we will convert the incomes into mid value. Then we will find out the cumulative mid value income. Then we will find out the cumulative percentage of the mid value income. Then we will find out we will write down the values of the workers, numbers of the workers, and we will find out the cumulative frequency of the workers, cumulative workers, and then we will convert the cumulative workers in terms of cumulative percentage, right? And after preparing this, we will be drawing a graph, and that will look like something like this. So you can see that we need to prepare two Lorenz curve here. We have prepared two Lorenz curve here, Lorenz curve A and Lorenz curve B, and you can clearly see that Lorenz curve of the factory B is farther from the line of equal distribution. That means there is a high degree of dispersion in case of factory B in the income of the workers working in the factory B, and workers working in the factory A have low degree of variation, right? So Lorenz curve falling closer to the line of equal distribution have low degree of dispersion, and Lorenz curve falling away from the line of equal distribution have greater degree of dispersion. Will you be able to do that? So shall
Yes,
I give
sir.
you as a homework now?
Yeah.
Okay, so this is it. This is all about this chapter, dispersion. With this, we comes to an end of this chapter. So I would recommend that you do as much question as you can, so that the concept of this chapter can it can get strong only when you will do questions on your own. And if you face any difficulty solving any question, or if you have any doubt regarding any specific topic discussed in this chapter, do let me know in the upcoming sessions, so that
Okay.
accordingly we will discuss those topics.
Okay, sir.
With
Sir,
this, yeah.
In what condition should we draw two Lorenz curve you said? Is there
What?
a separate?
No, see, whenever we need to present we have two information subject to one particular, how can I explain this? Like in this example, see, we have the information about the factory worker, factory A and factory B, with respect to income. So here we want to find out the dispersion among the workers working in factory and factory B with respect to income only. Getting my point? So if you want to find out the dispersion between two variable with respect to one particular variable, and in that case we will be preparing two Lorenz curve. Like
Okay.
in the previous question, there was no basis. We had to prepare a Lorenz curve about the firm A and firm B, but there was no specific basis on the basis of which we need to prepare the Lorenz. So therefore, we prepared one single Lorenz curve indicating the degree of variation between firm A and firm B. But in this question, we need to find out the dispersion between firm A and firm B with respect to the income. Factory A and factory B, we want to find out the dispersion between factory and factory B, but we want to find out that with respect to the income generated by worker working in these two factories. So therefore, we have decided that we will be preparing two different Lorenz curve. Okay.
Okay, sir.
So you will understand more when you will solve few questions based on Lorenz curve on your own. And still, if you have any doubt, then we will discuss this in the class.
Okay, sir.
All right. So with this, the syllabus of the statistics comes to an end, and I think in the microeconomics as well, we have completed everything now, or is there any specific?
Yes, sir. I think so.
Okay, so syllabus of the economics is completed. Only few sessions for the accounts will be required. So Alexander, just a minute. Yeah. So can we do one thing? Shall we shall we start the accounts, the remaining part of the account from the next session?
Okay, sir. No problem. No problem.
Okay, so we will discuss the remaining part of the accounts, rectification of error, in the from the next class onward. So we will be taking a regular classes. Tomorrow we have a class, and on Monday as well I'll take the class. And I think if since we have 2 hours for accounts only, so we will be able to complete our syllabus of the accounts as well in the probably in the next 2 sessions. All right.
Okay. Okay.
Okay. So this is it for now. But I would just recommend that you revise the entire concept. You do as much question as you can, and if you have any doubt and any query regarding any specific topic, then we will discuss by giving you extra time. Okay. So till
Okay,
then,
sir.
we will see you in tomorrow's class. Till then, take care. Goodbye. Good night.
Okay, sir. Okay, sir. Good night. Thank you. Bye.